Okay, so you should have watched a skateboarding video on explaining what acceleration is. And he did two of them really well, what is positive and negative acceleration. But there's a third way to accelerate. So before I get to that, I just want to do a quick review to remind you the difference between speed and acceleration. So speed is distance over time. And remember we said graphs are actually division bars. So my distance, my numerator, the top number, is my y-axis, and my denominator, time, is my bottom number. So by looking at this, I can tell it's a straight line, so it's a constant speed from Phoenix to Denver, I'm guessing once in the air, because this is an hour in and ending 7 hours after 0. So 7 minus 1 is 6. So I have a run of 6, but what's my rise? Well, I ended up 1,400 kilometers away, and I started at 2 from wherever the 0 point is. So 1,400 minus 200 is 1,200, and 1,200 divided by 6 is 200. And what would be my unit? Kilometers per hour. So 200 kilometers per hour at constant speed from Phoenix to Denver. Most things don't go at a constant speed, however. If we look here, we have a rise of 1 and a run of 1. So this one is going 1, again, kilometer per hour from this stretch to this stretch because it's the same. And then here, they're taking a break because there is no speed here. At this point, my distance is always 3 kilometers, but my time is passing. So this would be like I'm running, and I'm stopping. There is no speed if it was a speed graph, which it is. If it's acceleration, it means a whole different thing. So we'll get to that in a minute. And then they start running again, and I can again calculate my rise over run, which is 2 kilometers in 1 hour, so it's 2 kilometers per hour. So actually running faster, and you can tell that because it's a steeper line segment on my graph. My slope is steeper. So on a speed graph, shallower slopes means going slower. Flat slopes mean no speed at all, you've stopped. And this is acceleration. Or not acceleration, but they did accelerate at some point to get to a constant speed going faster on the steeper slope. So let's take a quick look at that. Which of these graphs would be going faster? Bob in red, Jane in black, or Leroy in blue? Well, who has the steepest slope? In this case, it's Leroy. Who's going the slowest? In this case, that's the shallower slope. That would be Bob. And who's going in between those two? It would be Jane. So Leroy is fastest, and Bob is the slowest. Let me reduce that just a little bit. All right, now let's get into acceleration. Skateboard guy did an incredibly good job, Dr. Bob, I believe, of explaining to you what acceleration is in the formula. And in case you've forgotten that formula, acceleration is equal to velocity final minus velocity initial. And the reason why we do these subscripts is because they're both velocities. Remember, speed with direction is velocity. So this is just differentiating my starting speed from my final speed, my end speed. And I divide that by time. Well, my acceleration can be positive or negative. He did a great job of explaining that. So if I increase speed, I get a positive acceleration. If I decrease my speed, we have a negative acceleration. We actually, in science, don't love the word deceleration. We actually prefer the term negative acceleration because scientifically that's just a little more accurate. But there is a third way. And think about this. Have you ever seen a skater pull their arms in? It makes them go faster and slower when they do that. Or have you ever seen like a chain of people on skates going in a circle, or there's one and everyone's pivoting around it? Well, acceleration also changes if I change direction, if I start to turn. Because think about it, my inner wheels have a short way to go, my outer wheels have a longer way to go, and you actually end up slowing down. So if you have your permit, or you're about to, and you go driving on 394, you know all those big curves? Well, in order to maintain a constant speed of 65 miles an hour on that road, I actually have to slightly accelerate to compensate for that friction of turning. So if you are on like a merry-go-round, you have constant acceleration. Even if you're going at constant speed, you have to be constantly adding energy. You have to be constantly accelerating to maintain that speed because you're losing a lot of it due to friction. So there's 3 ways of accelerating: to speed up, to slow down, or to turn. Guaranteed question on the test. You need to know the 3 ways in which you can accelerate. So if I look at this acceleration graph, you'll see that speed increases with time as accelerating, and a straight line is acceleration is constant. So in this case, if I continued this like this, and went like that, I could actually kind of look at the difference like we did on a speed graph. The difference is here, I still have time on the x-axis, but you're going to notice here that I have speed on the y-axis. And that means this is an acceleration graph. I'm dividing speed by time. And when you go into the next assignment, which is starting your math assignment, I'll actually break down looking at that a little more. But just so you know, your unit for acceleration could be meters per second per second. Otherwise, that can be written, and I'll explain this in the next video, as meters per second squared, and we'll break down the math as to why that's the same thing. It could be kilometers per hour per second. In that case, I can't combine these two because they're dissimilar units. But that means for every second that passes, let's put a 2 here, I'm going to increase my speed by 2 kilometers per hour. So that's the part of acceleration. It's your change of speed over this time unit. So if I have 1 second or 2 seconds or 3 seconds, and that's my time, my speed then would be 2 kilometers per hour after 1 second. Another second later, I'm increasing by another 2 kilometers, so I'd have 4 kilometers per hour. After 3 seconds, it would be 6 kilometers per hour. So this is my kilometers per hour, and that's why it's really important to understand that in acceleration, there's 2 things you're comparing: speed over time, and that's why we have 3 units here. So on this graph, this is a constant acceleration, I can actually follow that along, and I can figure out by how much it's accelerating. So if I start at 0 and go to 2, my run is 2, and my rise it's going back by 2, so it's 4. So this constant acceleration is 4 divided by 2, which is 2 meters per second per second. So every second that passes, I'm going to increase by 2. In this case, we'll pretend the kilometers not there. Meters per second per second. So that's a constant acceleration. If I have a flat line on an acceleration graph, it means I'm going a constant speed. And get this, if I get rid of this, let's take a quick look, and we're going to do one more thing with this graph, and I want to make it just a little bit different. So let's clean that up pretty for us. All right, so I just told you that this would be constant speed, no acceleration. If I shot up way higher, quicker, the steeper slope, that means that all of a sudden I've accelerated far faster than I was doing down here, and I could calculate it if I had a good graph. This again would be constant speed, but this is a negative acceleration. This is a positive acceleration. This is a positive acceleration. And this point and that point is constant speed. I'm not great at writing with mouse, but I'm getting a little better. So on an acceleration graph, the steepness of the slope tells me how fast I'm accelerating or decelerating. This would be a negative acceleration, but this would be like slamming into a brick wall because you came to a stop really fast. That is the 3 ways in which we can accelerate: turning, speeding up, or slowing down.